Hello everyone. Welcome to the solution of LeetCode problem 1302 named deepest leaf sum. In this problem, given the root of a binary tree and we have to return the sum of the values of its deepest leaves. So here we can see that in the first example, the root is 1, which has two children, 2 and 3. 2 has two children, 4 and 5. 4 has one children, 7. 3 has one children, 6, and 6 has one children, 8. So here the deepest level is 7 and 8, which is the level 4. So the summation of both of the node is 15, so we have to return 15. I hope you understood the problem statement. Now let's move on to the algorithm. In this problem, we have taken these examples. Here the root is 2 with two children, 3 and 1. 3 has one children, 3. 1 has two children, 1 and 1. And 1 has two children, 2 and 5. So this is the first level, this is the second level, this is the third level, and this is the fourth level. So this fourth level is the deepest level, and their summation will be 7, which is 2 plus 5. So we have to return 7. Now, the question is, how can we solve this problem? Basically, here the basic intuition is we have to deal with the level first. So if any kind of graph or tree related problem, we have to deal with the levels. We will use the BFS algorithm because BFS is the level-wise traversal. So in the BFS algorithm, we will take the advantage of a queue. So here, let's start the BFS from the root node 2 and insert it into the queue. So this is the first level, which is L1. Now, for the first level, let's remove it from the queue and insert its both of the left and right children. So we have to insert the value 3 and 1. So in the 3 and 1, let's insert them into a vector as well. So this is the vector with having the value 3 and 1 till now. So it is the level 2. Now, what is the front element of the queue? It is 3. So let's remove it and insert its left children 3 into the queue. Now, what is the front element of the queue? It is 1. And insert its both of the left and right children to the queue. So the queue will contain 3, 1 and 1. It is the level 3. So here in the third level, the vector will also contain the value 3, 1 and 1. Now, what is the front element of the queue? It is 3. But 3 does not have any of the left or right children, so we don't have to add anything into the queue. And what is the front element of the queue? It is 1. And here it has the left element 2 and the right element 5. So we will add 2 and 5 into the queue. Now again, what is the front element of the queue? It is 1. So it does not have any of the left or right children. So we will simply ignore it. So this 2 and 4 is the level 4, and let's insert them into a vector. And here, what is the front element of the queue? 2. So let's remove it from the queue. And it does not have any of the left or right children, so we don't have to add anything into queue. Similarly, for the node 5, it is a front element, and we will remove it, but we don't have to add anything in the queue because it does not have any of the left or right children. So far, actually, it is not 4, it is 5. So far, in the deepest leaf, we have the value 2 and 5. So here we can see that the summation of both of them will be 7. So here we can see that the summation of the deepest leaf is 2 plus 5, which is equal to 7, and we will return 7. I hope you understood the BFS algorithm. Now let's move on to the code. In this problem, the code is pretty simple. At first, we are given a function named deepest leaf sum, which has a root as a parameter. And if the root is null, we have to simply return 0. After that, we are taking a queue to store the tree node and initially inserting the root to the queue and taking a vector named deepest leaves. And we are running this loop until the queue is becoming empty. And here we are measuring the queue size and we are clearing the deepest leaf vector for each of the level. And for each of the queue element, we have to take the front element of the queue and store it into a node variable and remove it from the queue and insert the value of the front element into the deepest leaf. And if the front element has left and right children, we have to insert the left and right children to the queue. Finally, our deepest leaves will hold all of the node value in the deepest level. So we will run a loop and simply add them to an answer value. Finally, we have to return the answer. I hope you understood the code. Thank you everyone for watching the video. We will get back soon with another LeetCode solution.